We have a series regulator at the top, we have a shunt regulator at the bottom, both are closed loops, so they should self-regulate. Looking at the input regulation, if I change my input voltage by 10 volts, I get an output voltage change of about 0.2 volts. So line regulation, 0.2 volts change in output for 10 volt change in input, that's about 2%. What happens to the series regulator when the input voltage falls too far? Well, the output cannot be sustained because the Zener diode no longer has enough current. It needs at least 1 or 2 milliamps to sustain current flow, and as you can see, the output voltage collapsed. The load regulation on this circuit is quite good. As the load resistor goes up and down, the output voltage stays fairly constant until such time as the load resistor goes short circuit. So the current, as you can see, was increasing and decreasing with the load resistor change. And when we go to the animation, the red animation of the current will go more or less intense as the load resistor changes. And when it goes to a short circuit, the output voltage will collapse, and you can see the op amp will try and drive Q2 harder and harder to sustain the regulation, but it just cannot sustain it when it's a short circuit. So using the load regulation formula, V no load minus V full load over V full load times 100 over 1 to make a percentage, we would get better than 1% regulation, except when the load went down to 10 ohms or less. Looking at the bottom circuit, which is a shunt regulator, its output voltage is determined by R6, R8 and D2, and it's 7.5 volts. We've got 7.5 volts on the output, we've got 15 volts in the input, we've got 7.5 volts across R7, which is a 10 ohm resistor, 750 milliamps, and that's going to be shared between the load resistor VR2 and the transistor Q1. And as the load resistance changes, you'll see the current shifts its balance between the output and Q1, and the regulation is maintained until such time as the load goes short, in which time it does collapse the regulation. Again, the regulation on this circuit is better than 1%. When there's very little load current being drawn, most of the power has to be wasted in Q1, so it's not a very efficient circuit for high resistance loads. But as the load approaches short circuit, all the current is drawn to the load, and so it improves its efficiency all the way up until the point where it actually goes short circuit and the regulation collapses.